Hello everyone, welcome to Anonymous World. Hope you're all doing well. So today is day 9 of Advent of Cyber 2023. So let's get started. So day 9 is malware analysis. C shell, C sharp shells by the C2 shore. That's a nice name. Okay. So having retrieved a deleted version of the malware that allows Greedy to control else remotely, MacBlue and his team have started investigating to stop the mind control incident. Okay. So learning objectives for today, the foundation of analysis malware samples safely, the fundamentals of .NET binaries, and we will learn about DNS spy tool for decompiling malware samples written in .NET and building an essential methodology for analyzing malware source code. Okay, so there is one warning: handling a malware sample is dangerous. Always take precautions during your analysis. Okay, so a sandbox is like a pretend computer setup that acts like a real one, but it's actually not the real one, and it's a safe place for experts to test malware and see how it behaves without any danger. Okay, so start our G. See what we have. Okay, introduction to .NET compiled binaries. So these are compiled files containing code written in languages compatible with .NET framework such as C Sharp, VB.NET, F Sharp, or managed C++. Okay, these binaries are executable files with the .exe extension or dynamic link libraries, or we can also say that DLLs. Let's go ahead. So this may be a little bit overwhelming. In simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instructions. Meanwhile, a C-sharp binary can be decompiled and its source code retrieved since the intermediate language contains metadata. Okay. So after that, some basic of C-sharp programming is given there. If you know, then it's well and good. Otherwise, you can go through this code snippets and learn basics about spaces, classes, functions, and variables. So with that, okay, next is C2 primer. So according to Blue, the retrieved malware sample is presumed to be related to organization's remote mind control, or C2. Okay, command and control. So to build the right mindset in solving this case, let's look at the run through below about malware with C2 capabilities. Okay, so C2 is also known as command and control, which is a centralized system or infrastructure that malicious actors use to remotely manage and control compromised device or system. What it does that it serves as a channel through which attackers issue commands to compromised entities, enabling them to carry out various activities. Okay, so a diagram is given there for better understanding. So at first user executes the malware, then the malware gets connected to the C2 server and asks for instructions. And C2 server responds with certain set of instructions, and then victim malware executes the instruction retrieved from C2 server. And finally the malware reports back the output to the C2 server, and then what? Attacker connects the C2 server and issues commands to be executed on the victim machine. So 5 step and you are done. There are certain capabilities of malware with there are certain behaviors of malware suite capabilities like HTTP requests, command execution, which allows attacker to execute OS command inside the machine, and then sleep or delay. Okay, so we'll try to find these functionalities in the following section. So first, decompiling malware samples with DNS spy. So let's open DNS spy. So since we already assumed that a malware sample is written in C Sharp, we will use DNS spy to decompile the binary and review its source code. So what is the DNSPy? It is an open source .NET assembly, C# debugger and editor, and it is typically used for reverse engineering .NET applications and analyzing their code. Okay, so we won't be executing the malware here, so the debugging functionality will not be discussed in the following section. Okay, so to proceed, let's go to virtual machine. Okay, and start our DNSPy. Okay, so that's done. Once the tool is open, we will load the malware sample by navigating to file, open, located in upper side. Okay, Let's uh, maximize it, file, then open, and that's located in desktop inside artifacts. We need to select all files here. Yeah, so juicy tomato underscore we find. Open this. So now that we're inside the malware sample folder, okay, so we are done with that. So once the malware sample is loaded, you will have a view like the image below. Okay, so the image is pretty same. The next step is to click on the main string, which will take you to the entry point of the application. So click on the mains and it will take you. Then this is the entry point of the application. So there are functions given there like decryptor function, encryptor function, execute command, get it, implant, main, post it, sleeper. Okay, so the main function is like the entry point into the application. Like from here, all the rest of the functions are called. So let's go through all the function. So understanding the malware functionalities. Main function can be considered a modular code. During this allow us to easily break down the malware functionality without getting bogged down with long code snippets. Okay. So to start off, view the list of functions inside the program class by clicking the highlighted section. Okay, so we already did that. And after clicking, we will see certain more functions. Okay. So let's see, first function is get it function. Let's open our get it function. Okay. So based on the source code, get it function uses the web request class from the system.net. So we can see that it is using a web request function, web request class from the system.net namespace, and it is initialized by the function's URL argument. Okay, so you can see the user agent is given there. Note you can render the namespace details by hovering over the web request string, similar to what you see in the image. Okay, so you can just hover there to get more details. That's nothing much. So by default, the HTTP method is set to the web request class is get, and this means we can assume that the HTTP request made by the function is a get request. Okay, so this is making a get request with this user agent. Let's go ahead. So in other words, the getIt function accepts a URL as its argument, configures the parameter needed for the HTTP GET request custom user agent, and returns the value of the response. Now the second function is posted function. So similar to getIt function, this also uses the web request class, but it has some different configuration. So the most notable is the method property, wherein the value is set to post. Okay, so in the getIt function, the value was set to post. You can see here in the seventh line, HTTP web request dot method is equal to post, and in the getIt function, it was set to get. Okay, so simply the posted function accepts an additional argument as its post data, which is then submitted to target URL, and then it gives us the response. The third function is sleeper function. So it contains only a single line to call to the thread.sleep function. So it is just calling this particular function thread.sleep, and the thread.sleep function accepts an integer as its argument and makes the program pause for milliseconds based on the value passed to it. Okay, so it's a accept value as milliseconds. You can see the command function is being used here. Then the next one is execute command. Okay, so given the namespace and class name system dot diagnostic dot process, you can hover on process to see the namespace and class name of the initialized process class. See, the function is being used to spawn a process. So execute command is being used to spawn a process according to its documentation. You can read that. So here we can see that a file name is written cmd.exe, then our one argument is given /c, and then some plus command. So what we can understand with that, we can conclude that We can conclude that the file to be executed is cmd.exe and the execute commands argument command variable is being passed as a process argument. So in short, the code snippet will result as cmd.exe/c and then a command variable. Okay, moving forward. Another thing to note is that Windows style property is set to process.windows style.hidden. Okay, so you can see the first line Windows style. This means that the process will run without a window. As such, it's a way to hide the malware's malicious command execution. Like the victim won't be able to see that this particular command is uh, being running or being ran. Okay, so next we have encryptor. Okay, so the giveaways in this function are the AES classes used in the middle of the code block. Okay, so AES encryption is being used here, and it shows the namespace system.security.cryptography. So means that everything here is related to cryptography or encryption. We can see there is one key. You can hack the super secure C2 keys. It is getting encrypted. Moreover, the encryptor function accepts an argument and encryptor using the hard-coded key and IV values. And lastly, it encodes the encrypted byte into base 64 using the convert.to base 64 string function. Okay, last you can see return convert, and then it is converting the code to base 64 string. Then we have decryptor. So this function is just opposite of the encryptor, which expects a base 64 string to decode it and then proceed to the decryption to retrieve the plain text string. And the last function we have here is implant. So what it does, it accepts a URL, the string as its argument, initiates an HTTP request to the URL argument, and decodes it with base 64. You can see it's written convert dot from base 64 string. It also retrieves the app data path and attempts to write the content of base 64 decoded data into a file. You can see environment.special for the application data, then plus then one spikeit.exe is given there. So in context of malware function, implant function is a dropper function. This means it downloads and stores other malware inside the compromised machine. So once the machine is compromised, implant can be used to download and store other malwares too. Okay, let's see the question. You can go through the details of code. Let's see what we have in question. So first question, what HTTP user agent was used by my malware for its connection request to the C2 server? Using HTTP user agent is used by the malware for its connection to request to C2 server. Okay, let's try this. Okay, yeah, it's correct. So what is the HTTP method used to submit the command execution? So we are submitting something. So we can say that we are posting some data. So we can write that post. So what key is used by the malware to encrypt or decrypt the C2 data? So we just saw that the one key is given in encryption and as well as decryption. So it is using AES method. So key remains same. Okay. So what is the first HTTP URL used by the malware? We need to find the first HTTP URL. So let's go to main string. So we can see here host name is Dino and the string we have is HTTP MACD secret2.thm, and when you path is also being added here, which is reg to the URL string. So let's see if this is the correct one. Followed by reg. Yeah, that's the correct one. Now, how many seconds is the hard-coded value used by the sleep function? So when we go to sleeper function, there is uh, only one function, thread.sleep. Yeah. So let's go to main function, and here we will find our fed function. So our sleeper function is being used here, program.sleeper count, and we can see the value of count here is 15,000. So here the 15,000 it is written in milliseconds, but the function will take it in seconds. So 15,000 milliseconds is equal to 15 seconds. What is the C2 command the attacker uses to execute commands via cmd.exe? Okay, then let's go to execute command function. So what is the C2 command the attacker uses to execute command via cmd.exe? So you can see here the file name is cmd.exe and argument is c/c plus command. So we need to find this particular value of this particular command, string command. So let's get back to our main function and let's find the execute command function. See where is our execute command. Okay, so here is program.execute command text, and when it will get executed, so we can see it is under this if a is equal to shell. So when the value will be shell, then this gets executed. Okay, so shell. Now let's go ahead. So what is the domain used by the malware to download the another binary? So that is done using implant function. So spring as so there is a string variable text. Okay, so you can see environment.special folder application data, and then path is given spikey.exe. So we need to find the domain name. So let's go to main function again. Implant, we can find where is implant function. Yeah, so this is implant. Pay is equal to implant. A string text to program.implant http stats.migrate.hm. Then we have spikey.exe. So it is just asking about domain, so we can write till here. Okay, so there won't be http as well. So that was the correct answer. So that was it for today's challenge. You can check out the malware analysis module in the SOC level 2 part if you enjoyed analysis malware. That's it for this video. I will see you tomorrow in the next video. Till then, keep learning.